In this video, we're going to continue our world climate tour. In a previous video, we looked at tropical and subtropical climates. In this one, we're going to look at mid-latitude and polar climates. We're going to keep asking the geography question, which is what is where, why, and so what? And we're also going to keep using climate graphs, which are graphs that summarize a climate using two statistics, temperature and precipitation. Those same two statistics are what's used to create the Koppen system of classifying climates. So in the previous video, we looked at groups A and B in the Koppen system, which were tropical humid climates and then dry climates. And in this video, we'll look at C, D, and E, mild mid-latitude, severe mid-latitude, and then polar climates. And we'll also look at group H, which is a special group that was added to the Koppen system later. It was not part of the original system. And H is highland climates, which are simply based on elevation. So let's start with the mild mid-latitude climates, which is group C. You can see in the legend, there are actually three different categories within Group C. There's Mediterranean, there's Humid Subtropical, and there's Marine West Coast, also known as oceanic climates. So we're going to look at all three separately. But all three are on this map, and when we get to each one, I'll put an arrow in the legend that shows which one we're talking about, the right color. You can think of these mild mid-latitude climates as sort of transitions between the tropics, the tropical climates, and then the cold climates up to the north. So let's start with Mediterranean climates. These are climates that are wet for most of the year because they're found on west coasts of continents where the westerlies bring onshore winds. So they're going to have that maritime effect, plenty of moisture for most of the year. But what also separates Mediterranean climates and makes them unique is that they have a dry summer. And that's because they're temporarily going to be under the subtropical highs. If you remember, subtropical highs generally fall around 30 degrees directly down. They're also called the horse latitudes. It's vertical descending air. It's dry and cool. To give you an example, normally the subtropical highs hang out over the Sahara Desert and create that desert, the dry trade wind shooting out from there. But we know the Hadley cell moves up and down over the course of the year. And the subtropical highs are the blow dryer on the Hadley cell. So that blow dryer actually moves up during the summertime and it hovers over the Mediterranean. So the same dry air that creates the Sahara Desert in the summer is over the Mediterranean, over the south of France, Italy. By far the largest area of Mediterranean climates is the Mediterranean region, but it's found in small places in other parts of the world. For example, Southern California. And there, subtropical highs that normally hang out over the deserts of the Southwest in Mexico, like the Sonora and Chihuahua Desert, for example, they migrate up and catch Los Angeles and San Diego in the summer. So here's a climate graph of a Mediterranean climate in Malibu, California, which is not far from Los Angeles. Like we said, you can see there's precipitation for most of the year, except it fades away in the summer, where it becomes almost like a desert. And because of the maritime effect, the winter monthly averages are in the low 50s, and the summer monthly averages don't get above about 70. So that's a very narrow temperature range. When you have that descending cool air coming straight down on you from the subtropical highs in the summer, it creates clear skies with very few clouds. It's not going to rain very often at all. And the temperature will be a little cooler than normal. And so this creates great conditions for going to the beach. And that draws tourists from around the world to the French Riviera, the Spanish Costa del Sol, and to Southern California. For thousands of years, humans have learned to plant certain crops that thrive in Mediterranean climates, like grapes and olives. These are crops which actually taste better because of that dry summer. It makes the plant struggle, they say, which brings out nutrients and better flavors. The dry summers in Mediterranean climates also lead to summer wildfires every year. This is nothing new. You can read about it in the Greeks and Romans, and science has shown that these wildfires have existed for thousands of years before that. But what is new is that in the American West, these wildfires are spreading at an extremely fast rate and more intense than normal. What creates these summer wildfires is simply dry wood. For most of the year, we said you get onshore westerlies bringing moisture, and so it builds up the forests, for example, in California. You have all this wood, but then in the dry summer, that wood then dries out over 3-4 months. By the end of the summer, that's when the wildfires occur. A lightning bolt, a campfire gone bad, and the forest lights on fire. So what's behind the increasingly intense wildfires in the west coast of America is actually two things: bad forest policy over the last century, and then also simply having more stuff to burn out there. California was only really heavily settled in the middle of the 1800s with the gold rush. And then later with Hollywood and Silicon Valley and more migrations, you had it fill up with people. Today, Silicon Valley is the highest concentration of wealth in human history. So there's just many more human settlements with houses and other buildings to burn. But even more fundamentally than that, the US has had bad forest policy for the last century. In the early 1900s, the US made a policy of putting out every single forest fire as soon as possible. That sounds great, but unfortunately it's against nature. Nature uses forest fires to clear out dead wood and excess growth. So when you put out every single forest fire, you actually allow too many trees to grow in the forest. To where now there are 2 to 3 times the density of trees in California's forests. That creates way too much competition for water, and a lot of those trees can't survive. They die, and you end up with all this dead wood in forests. Add to that pests that have attacked these trees in the last couple decades, killed even more trees, and you have a huge amount of dead wood in the forests of California. So when something does create a fire, it rips through all that dead wood extremely fast. And that's the main cause of the increased intensity and speed of these fires. From the Mediterranean climates on the west coast, let's move to the east coast, the humid subtropical climates. This is the climate of Virginia. These are found on the east sides of continents, and the word humid here doesn't mean that it's humid all year. It doesn't mean that it's sticky all year. It simply means that there's no dry season. So when we look at the climate graph, we won't see rain drop out for any part of the year. Humid subtropical climates are also under the Westerlies, but they're coming from the continent, not from the ocean. So they're not going to have as much of the maritime effect. But there's two variations. In the summer, the winds can reverse because the trade winds can migrate high enough where they come onshore from the east. Those trade winds mostly hit places like Florida and the Gulf Coast, but sometimes they make it up to Virginia. And they bring tropical cyclones like hurricanes. Then in the winters, they're usually mild under the Westerlies, but then the polar front can migrate southward far enough where polar easterlies behind it can cover the areas in humid subtropical climates. That brings cold weather, and along the polar front brings storms like blizzards and the mid-latitude cyclones. You can see on this map that humid subtropical climates cover the whole US southeast, but they also cover the southeast of China and much of northern India, and also the southeast of South America. These are some of the world's biggest farming regions. Richmond, Virginia is a good example of a humid subtropical climate. It's got moisture throughout the year, snows in the winter, tropical storms in the summer, rains in the spring and fall, and it's got a pretty big range of monthly average temperatures, with January below 40s and the summer averages getting close to 80. Humid subtropical climates have a long growing season that lasts up to 8 months, and this creates some of the world's most productive farming regions. For example, the American South, the southeast part of China, and the Pampas of Argentina, Brazil, Uruguay, and Paraguay. Here in this picture, you see a tea plantation in Fujian, China. On plantations like these, they get 4 harvests per year because the growing season is so long. From humid subtropical climates, let's go back to the west coast, but let's move more towards the poles than the Mediterranean climates we saw before. Now we're going to move beyond the range of the subtropical highs. So there's not going to be any dry summer. It's going to be wet all year. And this is the marine west coast climate. Places like Ireland, London, or Seattle. It's found on the west sides of continents, but further towards the poles than the Mediterranean climates. Marine west coast climates are also sometimes called oceanic climates, and they're dominated by the maritime effect. So they're going to have a very narrow range of temperatures, and they're often going to be cloudy and have a lot of drizzle. So you can see on the map is this beige color, and it's up here in the northwestern part of the United States and Canada, and then also all of Northwest Europe, from the northern part of Spain and France, and Germany and the Benelux countries to the British Isles. London is a good example of a marine west coast climate. It's famous for lots of drizzle throughout the day. And on the climate graph, you can see it has a narrow range of temperatures, with the January averages about 40 and the July average in the 60s. So less than 30 degrees average monthly temperature range over the whole year. And when we see those tall bars of precipitation throughout the year, it's actually interesting to step back and think that we also saw tall bars like that in tropical countries, like in India, for example, in monsoon and rainforest climates. But the way that that rain is delivered is different in marine west coast climates versus the tropical climates. We could use an analogy of having a gallon of water and we want to put it on a garden. So there's different ways to do that. You could take a gallon of water, you can just dump it on the garden all at once. That will be sort of like your tropical storms that occur daily in tropical rainforest climates, just a lot of water all at once. Or we could attach a spray head to the top of that gallon and we could consistently spray it lightly throughout the day. And that will be like the marine west coast climate, which has lots of drizzle throughout the day to deliver all that rain. So the same amount of precipitation can arrive in very different ways. Ireland's nickname is the Emerald Isle. And that's because its marine west coast climate keeps it very wet. It allows for a lot of green vegetation to grow. They say the cows in Ireland eat more grass than any other cows in the world. You can find grass-fed Irish butter, for example, in supermarkets in the United States. The onshore rains of marine west coast climates also create rainforests, not tropical rainforests, but mid-latitude rainforests. These are found along the coast of marine west coast climates. For example, in Olympic National Park in this picture, up in Washington State, and also in New Zealand, for example, where they filmed Lord of the Rings in a rainforest like this. These mid-latitude or temperate rainforests are pretty rare today. But if we were to step back 500 or 1,000 years and go to, say, Ireland, we would see a lot more of these mid-latitude rainforests there. They've just been cut down to create farms and other human settlements. So now we've looked at Group C, the mild mid-latitude climates. Let's move up towards the poles to Group D, the severe mid-latitude climates, which are just like it sounds, more severe, more cold, more dark. And these are only going to be found in the northern hemisphere, in the latitudes between 40 and 70. And that's because if you look at 40 to 70 in the southern hemisphere, there's hardly any land there. And the land that is there is very narrow or small islands. And that means you can't have much of a continental effect because there's no real interior to the continent that you can go deep into. Whereas the severe mid-latitude climates are really defined largely by their continental effect. If you notice, the continents are at their widest in this part of the world. For example, if you look at the blue on the map, you can see it goes from the Pacific Ocean to the Atlantic Ocean, both in North America and also from Atlantic Europe all the way to the Russian Pacific. And because of that width, the continental effect can be extreme as you go towards the middle of that expanse. So let's start with the humid continental climates, which have a massive continental effect. They're found in the interiors and the east sides of continents, places like Chicago, for example. Another way to say it is that they're not found on the west sides of continents. They're not getting the maritime effect. Humid continental climates have very variable weather, meaning there's lots of change from day to day. Because when that polar front comes down in those northern latitudes, it's bringing polar easterly air behind it. It's very cold. So when it passes over places like Chicago, for example, the weather can change quickly from day to day. It can be 70 degrees on one day and then 7 the next. And we can see that big annual temperature range in this climate graph of Chicago, where you can see the monthly averages are in the 20s in January and in the 70s in the summer. And on this graph, you can also notice that a place like Chicago doesn't get a lot of precipitation in the year, but it is consistent throughout the year. Moscow in Russia is another example of the humid continental climate, with the average in January in the teens and in the summer about 68. And Moscow has a significantly higher latitude than Chicago, which makes it colder. And it also has a lot more precipitation than Chicago. So that shows you can have significant variations even within these climates. The warm summers and humid continental climates make them really good for farming. For example, on the Great Plains of the United States, there's the American Heartland, the breadbasket, where you have the corn belt, the wheat belt, even the dairy belt, like in this picture of Wisconsin on the left. And humid continental climates are found across northeast China, like the capital, Beijing, and the North China Plain, another one of the world's great farming areas, including the Yellow River Valley. The Yellow River is the mother river of China, and it's sustained civilizations for 5,000 years. From the humid continental climates, we can move even further towards the poles, toward the subarctic climates. These are places that are very dark because they have such low insolation from the sun, low energy. And winter is over half the year, so spring, summer, and fall are squashed and condensed into just a handful of months. Subarctic climates are where you find the coldest temperatures in the world outside of Antarctica because they have such extreme continental effects. A good example of that is Yakutsk, a city in Siberia. It's got one of the world's largest annual temperature ranges. The winter averages get down to about -40, while the summer averages get up to about 68. So that's a 108-degree range of temperatures averaged throughout the year. On the right, you see a fish market on the streets of Yakutsk. Like a lot of fish markets, the fish are frozen, but these fish don't require any refrigeration to be frozen. You simply put them out in the air and they get frozen solid, so they can stand them up like loaves of bread. Subarctic climates also contain a particular type of vegetation called coniferous forests. It just means cone-bearing trees, like pine trees and larch trees. These forests are often called boreal forests or taiga. Boreal means northern, and taiga is a Russian word that means snow forest. So you find these taiga forests across large parts of Alaska, Canada, and Russia. If you're ever wondering where IKEA first got the wood to make its furniture, Sweden and the other Nordic countries have lots of taiga in their northern regions. So most people in Sweden live along the bottom where it's warmer. But that country is actually pretty big, and it's got lots of wood from these taiga forests that you can use to make furniture. So from the severe mid-latitude climates, Group D, we can now go even further towards the poles, to the polar climates, Group E. These are climates with no months that average above 50, and the insolation they receive is very low. So they're extremely cold. And there's two groups, the tundra and the ice caps. Just to be clear, when we say the tundra climate, there's another type of tundra climate, which is the alpine tundra. Here we're going to be talking about Arctic tundra. The alpine tundra is in the mountains. The name comes from the Alps in Switzerland and France, etc. If you get high enough in the mountains, you can get tundra in certain areas because of the cold. But this is the Arctic tundra, which circles the Arctic Ocean. So if we look at this map, you can see that the tundra climate, the Arctic tundra, is found all around the edges of the Arctic Ocean. And on this map, it looks like a long line across the top, along the edges of the continents. If we were to take a globe and look at it in 3 dimensions, we could look down on the North Pole, and we would actually see that what this really is a ring around the edges of the Arctic Ocean. So the tundra climates in the Arctic sort of form this coastal ring around the edges of the Arctic Ocean at the top of the world. It's home to Eskimos and Inuit people and the Nenets, all these cold weather people who live along the Arctic shores, hunting seals and whales and reindeer. Tundra climates are very cold, but they don't get as cold as subarctic climates because the tundra climates actually have a maritime effect off the Arctic Ocean, which warms them up a little bit. The tundra climates are too cold for trees, and so tundra vegetation is all short vegetation, flowers and lichens and things like that. And that only shows up in the warm seasons, which are only a minority of the year. In Russia, for example, reindeer normally eat along the shores of the Arctic Ocean, right along the coast, because that's the only place nutrients can be found for most of the year during the winter. But in the brief summer, the tundra thaws out and the lichens start to grow across it, and the reindeer make a big migratory loop across Russia, and they eat all these lichens across the tundra landscape, and finally they make it back to the shores again before the winter comes back. We can see a tundra climate here in Nuuk, the capital of Greenland. If you look on the right, you can see Nuuk has no trees. It's simply too cold for trees. And on the left, you can see their January averages are about 5, and in the summer, it's in the 40s. So like we said, no polar climates average above 50 degrees at any month of the year. During those summer months, when the tundra thaws out and that vegetation shows up, you also get lots and lots of birds which migrate to the Arctic to breed from Latin America, from Africa, from Southeast Asia. The birds arrive in the summer, they lay eggs, the babies hatch, they learn to fly, and both the parents and the babies fly out before the winter comes back. So from the tundra climate, where only short vegetation grows, we can move even further toward the pole and finally reach the ice cap climate, where nothing grows. And ice cap climates create a permanent cover of ice and snow. It's only found in Antarctica and the interior of Greenland. Ice cap climates have the coldest temperatures on Earth in Antarctica. On this climate graph, you can see Izmit, a special place because it's where Alfred Wegener died on the ice. Alfred Wegener is the pioneer of the theory of continental drift, which later led to plate tectonics. He was a German meteorologist and scientist and explorer who liked to go to Greenland to study. And on his last expedition to Greenland, his team went out into the middle of the ice, and then he went back alone with his dogs and sled to try to get food along the coast, but he never made it. He died on the ice. And so they left him there because he liked to be out there in the middle of Greenland. And on the left, you can see that Izmit's winter averages get down to about -50, whereas in the summer, it's only about 10. So it's extremely cold. And when it comes to precipitation, ice cap climates are basically deserts, polar deserts. That's because it's simply too cold for any evaporation to take place. So if no water can evaporate up into the sky, form clouds, then nothing can come back down again as precipitation. And that's the case here. If you look at this climate graph from Antarctica, and look at the bottom where the precipitation bars are, there are none. The precipitation is 0 throughout the year. So while we often say that the largest desert in the world is the Sahara, technically speaking, you could also say the largest desert is the polar desert of Antarctica, which is even bigger. There's an interesting phenomenon which happens in the summer in Greenland. The massive Greenland ice sheet is several kilometers thick, and it covers 80% of Greenland. In the summertime, its surface melts under the sun. And the meltwater that runs off forms pristine rivers in a network that flow out over the ice and even down through the ice, through holes like Swiss cheese, and all runs out into the ocean. A few years ago, a team from the UCLA Geography Department under Lawrence Smith went out there and camped out on the ice in Greenland in the summer and tried to measure these rivers. They measured the velocity and the volume of the water, and they also put GPS devices in there on drone boats, little remote control boats, and mapped where these rivers went. And what they found was that all the meltwater, whether it was over the surface or then through the ice, ended up in the global oceans around it. And the reason that research is significant is because the Greenland ice sheet is sort of an indicator, a canary in the coal mine for global warming. Just to step back, global warming is taking place in the polar regions like Greenland at twice the rate of the rest of the world. So people often use Greenland as a barometer to see what's happening with global warming because it's happening twice as fast up there. And because there's so much ice locked up in the Greenland ice sheet and other ice sheets, it's a good way to estimate how much the global sea level would rise if a significant part of that ice were to melt. Scientists have tracked the melting of the Greenland ice sheet for a long time, and the rate at which it's melting each summer has increased. Essentially, it goes through an annual cycle where in the summertime, the surface of the Greenland ice sheet melts, goes into the ocean. And in the winter, the water snows back in and builds up and refreezes as ice again. So there's an annual cycle of melting and then refreezing and building the glaciers again. Now that we've reached the poles, we can go to the special climate, Group H, which is designated just because of elevation. It's the highland climates. In the previous video on the ingredients of climate, the local and regional factors, we looked at what exactly makes climate different at high elevations. And here we can simply say that it gets colder and the air gets thinner as you go up onto mountains and plateaus. For example, in this picture, you see Mount Kilimanjaro, which is in a tropical location in Tanzania in East Africa, right near the equator. That place is very, very warm. It's where giraffes and elephants and lions hang out. But if you go up to the top of Mount Kilimanjaro, you see snow and ice up there. And that's simply because of elevation. Tibet in China is a good example of the highland climate. Tibet is the world's largest and highest plateau, located in southwestern China where it meets the Himalayas. And Tibet is often called the third pole because there's the third largest amount of ice after the northern and southern polar regions. But Tibet's cold temperatures have nothing to do with being at a high latitude where there's low insolation. It actually gets lots of insolation because if you look at the map, it's in a subtropical and mid-latitude location near India and southern China. So the reason for all the ice in Tibet is simply elevation. Tibetan people are traditionally nomads, and you see this Tibetan man on the right with his yak. Tibetan people eat yak yogurt, yak milk, yak butter, and they're famous for drinking yak butter tea, which is a tea where they put it in a blender and they put yak butter in it to make it extremely rich, and then they blend it all up and drink it. Ice in Tibet feeds major rivers of Asia. If you look on the map, down from Tibet flows the Yellow River and the Yangtze River, the two largest rivers in China. And they're fed by the melting ice from up there on Tibet, the rooftop of the world. That ice also feeds the Mekong River, which is sort of the Mississippi River of Southeast Asia. It runs through many countries and then out to the ocean through Vietnam. And Tibet's ice also feeds the rivers of Myanmar, like the Irrawaddy and the Salween. So this is one reason why China holds on to Tibet so tightly, because it wants to control the source of its biggest rivers. So that's a look at mid-latitude and polar climates. We saw how these climates are formed by a combination of ingredients, from the global winds to insolation to the maritime and continental effects. And we also saw some ways that humans have adapted to these climates to sustain life.